Welcome you all in this video lecture on your pipes and cisterns. In this lecture we will study some basics of pipes and cisterns, and we will solve few problems by using basics, as well as we will use shortcut and tricks also. So let us start with the concept. Before starting concept, you must know few terms related to this, that is inlet pipe, outlet pipe, and what is cistern. So inlet pipe is the pipe through which the water is coming in and filling the tank. Outlet pipe is the pipe through which water is going out and emptying the tank. Tank and cistern is one and the same one. Now you must know the concept of inversion for solving the problems. And what is the concept of inversion? Suppose, for example, the pipe fills the tank in 4 hours, then in 1 hour 1/4 amount of tank will be filled. And if you have been given with 1 hour 1/4 amount of tank is filled by one of the pipe, then what time is required to fill the tank? That you can find by making the inversion of that 1/4. Inversion of 1/4 will be 4. That is nothing but, in short, it will be represented in the diagram. If suppose n hours is required to fill the tank completely, then in 1 hour that tank will be filled 1 upon n. And if suppose 1 upon n is the time required to fill the tank in 1 hour, then the total tank will be filled in reciprocal of it, that is in an hour. So this is also possible in case of emptying the tank. If suppose one pipe is emptying the tank in 6 hours completely, then in 1 hour 1/6 amount of water, 1/6 amount of tank will be emptied. In vice versa, you can say it as in 1 hour, if suppose 1/6 amount of a tank is emptied, then time required to completely empty the tank will be reciprocal of this 1/6, that is 6 hours. So if you know the concept of this reciprocal or inversion, then you can solve many problems or many cases in that pipes and cisterns. So next point is some points to remember, or some cases to be remembered in this pipes and cisterns. So first case is, if suppose inlet is coming to the tank and fill in x hours completely, then the part of the tank filled in 1 hour will be reciprocal of it, that is 1 upon x. Similarly, if an outlet is connected to the tank and emptying the tank in y hour completely, then the part of the tank emptied in 1 hour will be reciprocal of it, that is 1 upon y. Next point, if an inlet can fill the tank in x hours, an outlet can empty the same tank in y hours separately if both the pipes are operated at the same time, and if y is greater than x, that is nothing but time required to empty the tank is greater than time required to fill the tank, then the net part of the tank filled in 1 hour will be 1 upon x minus 1 upon y. So here y value is greater than x, that's why 1 upon x minus 1 upon y is done. And other way also you can say it as a x is the time required to fill the tank and y is the time required to empty the tank. Therefore to x we have given a plus sign, and to y we have given a minus sign, and we have subtracted the capacity of each inlet and outlet pipes. So in another way also we can say it as a, if suppose both pipes are operated at the same time and x is greater than y, and more amount of water is flowing out, because time required to fill the tank is greater than time required to empty the tank. X is greater than y, therefore more amount of water is flowing out of the tank than the flowing into tank, and the net part of the tank emptied in 1 hour will be 1 upon y minus 1 upon x. Because here value of x is greater, therefore reciprocal of it will be less than 1 upon y, therefore 1 upon y minus 1 upon x. If any student can do this calculation like this, 1 upon x minus 1 upon y also, then for this next second case you will get the value as a negative, and that negative value means more amount of water is flowing out. So no problem will be there if you do 1 upon x minus 1 upon y for this also, but you will get the minus value. Next, if an inlet can fill the tank in x hours and another inlet is also there and which can fill the tank separately in y hours, individually these are having capacities x and y hours to fill the tank. If both the inlets are open at the same time, the net part of the tank filled in 1 hour will be 1 upon x plus 1 upon y. simply addition of these reciprocals will be there. Similarly, if two outlets are there which are emptying the tank in x hours and y hours separately, if both are open at the same time, then time required to empty the tank then the tank emptied in 1 hour will be 1 upon x plus 1 upon y. If we open the both pipes togetherly, then that will be time required. If you know these 4 points, then we can solve any problem on pipes and cisterns. We will start with the first problem. If suppose two pipes A and B can fill the tank in 20 and 30 minutes respectively, if both pipes are used together, then how long will it take to fill the tank? Two pipes are there, and these are having capacities 20 one can fill in 20 minutes, another can fill in 30 minutes. So we can find the how much part of the tank will be filled in 1 minute. Previously, while looking to the cases, we have seen all the values in hours. Here all the values are given in minutes in the problem. Therefore, we will find out the part of the tank filled in 1 minute by A pipe and B pipe, and that will be the reciprocal of these times, 1 upon 20 and 1 upon 30. And both pipes are filling the tank. That's why we can make the addition of these capacities of pipe A and B. Therefore, this addition 1 upon 20 plus 1 upon 30 will be 1 upon 12. And if you take the inversion or reciprocal of this 1 upon 12, then you will get the value of time required to fill the tank completely. Because in 1 minute, tank is filling 1 by 12 part. Therefore, time required to fill completely, you have to use the concept of invert and make the inversion of 1 upon 12. You will get the 12 minute as the value of time required to fill the tank completely if both the pipes are open. So next problem, pipes A, B can fill the tank in 5 and 6 hours respectively, and C pipe is emptying it in 12 hours. Now here two inlet pipes are there and one outlet pipe is there. If all the three pipes are open together, then tank will be filled in. So here we can find the capacities of pipe A and B as a reciprocal of these 5 and 6 hours. The part filled by the pipe A in 1 hour will be 1 upon 5, and the part filled by pipe B in 1 hour will be 1 upon 6. Similarly, the part emptied by the pipe C in 1 hour will be 1 upon 12. So all the pipes are open at a time. That's why we have to make the addition of the pipes which are filling the tank, and we have to subtract the pipe capacity of the pipe which is emptying the tank. Therefore, net part filled by the three pipes in 1 hour will be 1 upon 5 plus 1 upon 6 minus 1 upon 12. That is 17 by 60. But this is not our answer. This is the part filled by the all three pipes in 1 hour. We have to take the inversion of this, that is by the concept of invert. We have to make the inversion of this, that is 60 by 17. This will be the time required to fill tank completely, and that is 3 complete hours. 9 by 17 hours will be the answer. Next problem. So 3 pipes A, B, C can fill the tank from empty to full in 30 minutes, 20 minutes and 10 minutes respectively. When the tank is empty, all 3 pipes are opened. A, B, C discharges the chemical solutions P, Q, R respectively. What is the proportion of the solution R in liquid in the tank after 3 minutes? That means capacities of pipes A, B, C are given, and these A, B, C are filling some chemical solution in tank, that is P, Q, R respectively. Then we have been asked in 3 minutes, after 3 minutes, what is the proportion of that solution R with respect to total solution prepared by PQR in 3 minutes. So we can find the capacity of each pipe, that is part filled by the A pipe in 1 minute 1 upon 30, part filled by pipe B in 1 minute 1 upon 20, and similarly for part filled by C in 1 minute is 1 upon 10. So if we have been asked to find the proportion of R. Therefore, we will find out first that R is discharged by pipe C. Therefore, we will find the Therefore, we will find the part of the tank which is filled by the pipe C in 3 minutes. So capacity of pipe C is 1 upon 10. In 3 minutes, it can fill 3 into 1 upon 10. It will be 3 by 10. This is the capacity of the pipe C in 3 minutes. And its proportion is asked with respect to solution filled by all three pipes. That is nothing but 1 upon 30 plus 1 upon 20 plus 1 upon 10. That is 11 by 16 part will be filled by all three pipes togetherly in 1 minute. But we have been asked to find out with respect to 3 minutes. Therefore, multiply it by 3. You will get 11 by 20 is the part of the tank filled by the three pipes together in 3 minutes. Isn't it? And the ratio of these two is asked, that is required proportion is 3 by 10 divided by 11 by 20, and you will get it as a 6 by 11. So this is our answer. 6 by 11 is the proportion of solution R in liquid with respect to other solutions in 3 minutes. So same problem we can solve by another method, that is a proportion method. In short, this is the shortcut for this problem. Now, you know that the ratio of the water filled by A, B, C per minute. That's the ratio of the chemicals filled by A, B, C per minute. You can find, you know, the capacity of pipe A is 1 upon 30, capacity of pipe B is 1 upon 20, capacity of pipe C is 1 upon 10. Therefore, ratio of these three will be 2:3:6. And A is filling the solution P, B is filling the solution Q, and C is filling the solution R. And we have been asked to find out the proportion of R at any time will be 6 upon addition of all these proportions, that is 2 plus 3 plus 6. It will be 6 upon 11. This will be shortcut for this problem. Easily you can find out proportion of other chemicals also. Suppose proportion of P solution you want to find out, then the proportion of P will be, what is the ratio of P here? Ratio of P is ratio of A, and it is 2. Therefore 2 divided by 2 plus 3 plus 6, it is 11. Therefore 2 by 11 will be the answer if proportion of P is asked. If proportion of Q is asked, then the solution will be 3 upon 11. So like this you can find out the proportion of any with respect to others by using a ratio method. Understand? Next problem. So suppose three types A, B, C can fill the tank in 12, 15 and 20 hours respectively. If A is open at all the time and B and C are open for 1 hour each alternately, then the tank will be filled in. Now here three pipes are given and all three pipes are filling the tank, but A pipe is open at all the times and B and C pipes are open for 1 hour alternately. Yes, so we can find the capacity of each pipe to fill the water in 1 hour will be 1 upon 12, 1 upon 15 and 1 upon 20 respectively. This is the capacity of each pipe. Just we have taken reciprocal of each hours. Then in first hour A and B are open. In second hour A and C will be open because A is open at all the time and B and C are making alternately after 1 hour. Therefore this pattern is going on till the tank is filled. So first we will consider the part filled by A and B in 1 hour will be 1 upon 12 plus 1 upon 15 because both the pipes are open. Therefore addition of these capacities will be there, 1 upon 12 plus 1 upon 15. It will be 9 by 60, that is 3 by 20. And the part filled by the tank by pipes A and C in 1 hour will be 1 upon 12 plus 1 upon 20, it is 2 by 15. So in 2 hours you have got the value 3 plus 20, 3 by 20 plus 2 by 15 is equal to 17 by 60. In 2 hours 17 by 60 part of the tank will be get filling. So in 6 hours, let us consider now suppose 6 hours. In 6 hours part filled will be the 3 into 17 by 60. Why 3? Because 2 into 3 is 6 hours. Therefore on right hand side also multiply by 3. 17 into 3 divided by 60, you will get 17 divided by 20. So that much part will be filled in 6 hours. Now what is the part remain to be full? That can be found by 1 minus 17 by 20, it is 3 by 20. So 3 by 20 part is remain to full after 3 hours. So that part can be filled by A and B pipes in the 7th hour, because the capacity of A and B pipe is 3 by 20 only, and that is the 7th hour we have to use. Therefore in 7 hours totally tank will get filled. This is a little bit conceptual problem. I think you have understood, because the capacity of each pipe is also given, and one condition is given that A pipe will be open throughout the end, but B and C pipes are open alternately for each hour. So in this case you have to solve problem like this only. Next, fifth problem we will see. A tank is filled in 10 hours by 3 pipes A, B and C, and the C pipe is twice as fast as B pipe is twice as fast as A. So the speed of the pipe to fill the tank is given here. One thing you must know, that if speed of the pipe is more, then the time required to fill that tank by that pipe will be less. As speed is more, time required will be less here. So how much time will the pipe A alone can take to fill the tank? So here let us assume the pipe A can fill the tank in X hours. Therefore what will be the time required to fill the tank by B? Because B pipe is twice as fast as A, therefore time required will be half than A. Remember this thing, if B pipe is twice as fast as A, therefore time required by B pipe will be half than A. Therefore time required for B to fill the tank will be X by 2 hours. Similarly, C pipe is twice as fast as B, therefore time required by C pipe will be half than the time required by B. Time required by B is X by 2, therefore time required by pipe C will be X by 4 hours. This is the time required by each pipe, X by 2 and X by 4. Now we will find out the capacity of each pipe. Now capacity we can find out by the reciprocal of these times, that is 1 upon X, 1 upon X by 2, 1 upon X by 4. That reciprocal you have got as 1 upon X, 2 by X and 4 by X. Now if all pipes are open at a time, then the part filled in 1 hour will be 1 upon X plus 2 upon X plus 4 upon X, it is equal to 7 by X. That much part will be filled in 1 hour. But in problem it is given that total tank is filled in 10 hours. Therefore we can equate this 7 by X, reciprocal of that 7 by X, that is X by 7, will be time required to fill tank completely equal to 10 hours, and we will get value of X is equal to 70 hours. So finally our answer will be 70 hours time required by the A pipe to fill the tank alone. So this is the as usual conceptual method, but in short you can find it by using a proportion also, method of proportion. Now the efficiency of each pipe you can see it from the problem statement. Pipe C is twice as fast as B, therefore, and B is twice as fast as A, therefore we'll consider capacity of A, efficiency of A is equal to 1, efficiency of B will be 2 because it is twice as fast as A, efficiency of C will be twice as fast as B, therefore it will be 4. Therefore efficiencies of these pipes A, B, C will be 1:2:4. This will be the proportion. If this will be the proportion, then then in 10 hours the part filled by the tank by A pipe only can be found by 1 upon addition of this proportion, that is 1 plus 2 plus 4 is 1 upon 7. So in 10 hours 1 upon 7 part will be filled, but now therefore pipe A alone requires 10 into 7 hours, because the reciprocal of 1 upon 7 is 7 into 10, you will get the 70 hours to fill the tank. This is the shortcut method. By using proportions you can find the value of time required by pipe A alone to fill the tank. So thanks for watching the video, and if you have any query, write in the comment box, and don't forget to subscribe the channel. Thank you very much.